Okay, so today we talked about an introduction to probability. This is the very beginning of a new unit. This is an easy unit if you're here and you're paying attention, so make sure to take some good notes and ask lots of questions. So probability is a measure of how likely something is to occur. So if you're talking the probability that you're going to be a teenager, right, that you're going to get your driver's license, that's probably a pretty good probability. It's going to have what we call a high probability. If you're talking about cats sprouting wings and flying tomorrow, probably not such a good probability. We call that a low probability. Probability is a measure of chance, what the chances are that something will happen. So something that can never happen has a 0% chance of occurring. We say that that probability is 0, right? 0% has a probability of 0. Something that's sure to happen, something that absolutely will happen, has a 100% chance of occurring, and we say that it has a probability of 1. We'll talk more about the numbers of probability later. Right now we're going to go through some definitions you need, so you definitely need your notebook out right now. In the study of probability, there are experiments and outcomes, just like in your science class. When you go in to do a lab, you do an experiment and you observe the outcome. So an experiment we're going to define as any process that has observable results, results that you can see. And outcomes, we're going to define those as the observable results. So the set of all possible outcomes is called the sample space. So every possible outcome for your experiment is going to be a sample space. And an outcome or a set of outcomes of an experiment is called an event. So I should actually redefine this. We should say that one outcome is called an event. A set of outcomes are called events. Okay, that way we're using proper English. So therefore, an event is a subset of the sample space. An event, or I should say a set of events, is a subset of the sample space. We're going to go over subsets again in just a second, but a subset for now we're just going to say is a set whose elements are in another set. So let's see if we can put this in a way that will make a lot more sense. So we have this sample space. All the outcomes of an experiment are going to be within this sample space. An event or events that include one or more of those outcomes is within that sample space. So these events are a subset of our sample space. One item or one event is called an element. We call that element a member of the set. So if this event were our class and the sample space was the whole school, one person in our class, or even you, would be a member or an element of our class. A set with no elements whatsoever is called an empty set. So maybe if I were talking about people with blue hair in our class, maybe we have people with blue hair, maybe we don't. In a class where we wouldn't have any people with blue hair, that would be an empty set. An empty set can also be called a null set. Let's put this into a little bit of perspective. So let's talk about students in this class again. All students in this class would be the set or sample space. So the whole class, we're going to call that a sample space. Just the girls in the class would be a subset of the whole class. We could have another subset of our class, and we could include people with brown hair. Is there a chance that my subsets will overlap? Of course, because I can have girls with brown hair in the class. One girl with brown hair, let me erase this other dot for just a second. One girl with brown hair would be called an element, and she would be in this place where the two subsets overlap. A girl without brown hair would also be an element. The reason I had this other dot up here is because a person over here would not be a girl, would not have brown hair. That's still an element in my class, right, in my sample space, but it's just not in either of these two subsets. Okay, so let's go over just a little more about sets. Let's call my class Set A. We're going to call Mr. Terry's class Set B. The sample space, we're going to call the two classes together. So in my class, where the black dots are, I have students that Mr. Terry doesn't have in his classes. This is called the complement of B. We write that as a capital B with a line over the top. And the complement of B means that all elements that are not in B. So those would be, in this case, students that I have that Mr. Terry doesn't. Everything outside of Set B. Then Mr. Terry has students that I don't have in my classes. So those are the green dots. And we're going to call that the complement of A. We write it as a capital A with a line over the top. And that means all elements that are outside of Set A. Then we have students that are in both of our classes, and those would be these red dots in the middle. We're going to call that the intersection, right? Where the two circles overlap, or where the two sets overlap, that's going to be called the intersection. And notice the notation. We use an upside down U, no tail on it, okay? And that's called the intersection. So we say this, the intersection of A and B. If I include everything that's in both sets, it could be A or B or both, then I'm talking about the union of the two sets. The union means everything that's in both sets, and it can be either one set or the other or both. So union, notice the word or here. Union means or, and I notate that with an upside right U. This says the union of A and B, and it means everything in the two sets. So let's practice just a little bit. Let's let our sample space be all whole numbers from 1 to 15. I have three subsets, Set A, Set B, and Set C, that are all three subsets of my sample space. Let's take a look at what the union of B and C would look like. So B and C, right? B is 2, 4, 6, 8, 10. C is 3, 6, 9, 12, 15. Union, remember, means or. The numbers either have to be in Set B or Set C. This is what my union set would look like. Notice how I have 2 6s. I would only write those 6s once. I don't have to repeat a number. How about A union B? What would that look like? Again, write all of your numbers in numerical order, no repetition, no repeating, and the union of the two sets would be 1, 2, 3, 4, 5, 6, 8, and 10. I include all numbers that are in A or B, or both, of course. How about the intersection of A and B? Intersection means and. Those would be numbers that would be in A and B, both. In this case, 2 and 4 would be the the intersection of A and B, right? Those are the only two numbers that are in both at the same time. How about the intersection of A and C? Did you say 3? If so, great job. If not, go back and look at the definition one more time. And how about the complement of A? Remember, complement means everything outside of set A. So my sample space, it's important to remember that our sample space are all the whole numbers between 1 and 15. So all of these elements need to be included except for the elements in set A. So if I were to write the complement of A, it would be everything from 1 to 15 except for 1, 2, 3, 4, and 5. And finally, how about the complement of the union of A and C? When you look at a problem like this, look at the union of A and C first. Union, remember, means all of the numbers that are in A or C. The complement means everything in my sample space that's not in one of those two sets. So everything from 1 to 15 except for 1, 2, 3, 4, 5, 3, 6, 9, 12, and 15. So all I would have left is 7, 8, 10, 11, 13, and 14. That's all we've got for today. If you have questions on intersection and union or complement, make sure that you ask right away. Have a great day, and I'll see you later.